Hello, welcome again to the online video lecture series Essentials of MATLAB. This is chapter 5 Errors, Pitfalls and Debugging. These are the contents of this chapter: syntax error, pitfalls and surprises, error in logic, rounding trapping, manual debugging and autonomous debugging. Whenever we are doing programming in any kind of language, so usually we face lots of error. So the main thing is, first you have to identify that where the error is. When you find the error, then you can easily debug that error also. First thing is how to identify that where the error is and what is the error. So we will see all the types of the error that can be present in the programming, and we will see how to debug that kind of errors. So the first topic is syntax errors. Basically, syntax error, if you talk about any kind of programming language, then usually 90% of the errors you are facing are of the syntax error. Syntax error means whatever the particular syntax or whatever the particular format is given to you, you are not following that syntax. Or you can say there is some spelling mistake. Like, for example, you have write plot, this is the exact syntax, or we can say spelling of the plot is this, but you have write plog, so there is a spelling mistake, or you can say syntax error. For example, the else if, in the else if you have used the space here, that will also be a error. So just analyze this line. So is there any kind of error? So if you analyze this line, you can easily notice that the closing brackets are not present. So it's simply written here, this is the bracket, and we have not put a closing bracket here. So this command will give you an error that expected this form. So you have to put an closing bracket at the end of this line. Okay, so let's see for this kind of cases what are the errors that MATLAB will provide you. Just write plot. Okay, and let's suppose we are having two variables. These are two variables, and let's just write plog x comma y. Okay, when you press enter, it will show you an error, undefined function plog. So undefined function means this function is not defined already in MATLAB, so you can easily identify that there is a syntax error in this function. Okay, and it also show you the regarding suggestion, like plog is somewhat similar to the log. So it asks you, did you mean the log? But if you didn't mean the log, you can delete this thing and again write the plot x comma y simply. Okay, so in this way you can easily read the error and you can debug that error. The error provided by the MATLAB is very simple to read and very simple to identify. Okay, so the next line is 1 2 3. This is a vector, 1 cross 3 vector, and you have to multiply it by 4 5 6. It's also 1 cross 3 vector. So is there any kind of error in this vector multiplication? So yes, basically there is an error. Either you have to put a dot operator here, or it will give you an error that inner matrix dimension must be agree, because 1 cross 3 and 1 cross 3, the inner dimensions are not agree. So it is an error in matrix multiplication according to the mathematics rule. And there is a function, this is the last error, so it's showing you the last error. So by this way you can just retrieve the previous error and you can show these errors, or you can save this error. So this is all about the syntax error. Basically syntax error is the main important thing. So whenever you are facing the problem like undefined function or undefined variable, then do check your spellings and the syntax format. The next is pitfalls and surprises. Pitfall and surprises means, basically pitfall means that where the chances of error are more. So there are some pitfalls. Let's discuss that thing so that you can avoid that error in advance. So this is a program to plot a sine wave. So just read this program and can you tell me, is there any kind of error? Basically there is no syntax error. So just analyze if there is any other kind of error. So in this program, basically the error will be the vector length must be same. As I have already explained this thing in the graphics chapter, that when you are using the graphic function like plot, then these two arguments must have the same vector length. So let's analyze how the vector lengths are different. In this thing you have written x 0 to pi, 0 to 3 pi, and the step size is pi by 20. So now suppose there are 100 samples and we have computed sin x for these 100 samples. Okay. Now we have changed the step size of the x pi by 40. Now the sample will be changed. So maybe there are 200 samples. So now x is having 200 samples and y is having 100 samples. So the length of these two vectors must be same for the plotting. So in the graphics, this is the most common error you will be facing. So just avoid this thing that you must have the equal vector lengths. So if you are not having the equal vector lengths, you will be facing the error as vector must be of the same length. Next is the name hiding error. In the name hiding error, basically, suppose you have defined a variable and there is already a file or a function present in the MATLAB. It's same as a variable. Suppose you have defined a script file like my_add. My_add is your script file. It is saved in the current directory. Okay. But suppose you forget that the particular file is available in MATLAB already, and you defined another variable same name as the my variable, my var. Okay. So now when you will call the variable, MATLAB's compiler will confuse that it should call the variable or it should call the file. So it is basically called as the name hiding error. Okay. And there's a one more error when you are calling the function. So it should be in the current directory. So if you are calling a function which is not in current directory, it will provide you the error. It is already described in the functions chapter that you must call the function when it is only in the current directory. Okay. So next is error in logic. Basically these are the errors. These are actually in the algorithm. When your program is running smoothly, there is no kind of syntax error, but still you are getting the wrong results. This kind of error is the logical error, and these are the most difficult type of errors. So we will also see how to debug that kind of errors. First, let's see some of the remedies that when you are getting the wrong results but your program is right. I mean syntax is right. It's run by the compiler but you're getting the wrong result. So if this is the case with your program, then just try to run the program for some special cases where you know the answers. Suppose like in case cos 90 degree it's always 0. Similarly, you must be having some special cases where you are having the values that you know already. So if the answer for that special cases is wrong, then you can recheck the values. And the next is, if you don't know any exact answer or any special cases, then you can try to use your insight into the problem for the range. Okay, to check whether the answer seems to be of the right order of the magnitude. Suppose if you are calculating the length but the answer is negative, so length can never be negative. So in this way you can know that whether your answer is right or wrong. Suppose you don't know the special case and you also don't know the range, then there is only one remedy left behind, is that try solving your program by your hand in your notebook. Okay. Otherwise there are some options that are provided in MATLAB that you need not to solve all the program in the notebook. So let's see some of the methods how to debug them. So basically before debugging there is a last type of the error, that is the rounding error, rounding or approximation error. If you read this program is syntax wise exact right and the logic is also right, but when you will run this program it will take a very long time. Okay, why? Let's analyze this program. So in this program, at while x is not equal to 0.2, you are adding this value. This value is very small, so you must have increased this value like 0.1 or 0.01, because if you are not increasing this value and if you are taking too much small value, this program will take lots of time, or this will consume your all the time of your program, and that will be troublesome. So let's see the manual debugging. In the manual debugging, you can use the pause as your debugger. So let's analyze how we can use pause for the manual debugging for the previous case. So let's see a program in which the syntax is right but the logic is wrong. Okay. So in this program, we are just finding out the even and odd number. If the number is odd, we are multiplying it by 5, and if it is even, we are dividing it by 5. So the logic we have used here is floor. Okay. So floor means it will give you a smaller integer. Okay. So suppose if it is an odd number, so you will be writing floor of 3 by 2. So actually 3 by 2 is 1.5. So the smaller integer to the 1.5 is 1. Okay. So floor of 3 by 2 is always less than 3 by 2. Okay, so it is true, is a true condition. So if the floor of odd number or floor of any number is smaller by its division of 2, then we will call it as the odd number. And if it is equal, or we can say if the either case happens, then it is an even number. Okay, so let's just run this program. So we are having x here and result here. So if you analyze closely these two results, so this was the input matrix and this is the output matrix. So each of the value in this matrix is multiplied by the 5 in comparison to this matrix. So it means either all the numbers are odd or this loop is not compiled, or we can say this loop is not processed. So let's see, the numbers, all the numbers are not odd, we are having even numbers also. First let's analyze that whether this loop is running exactly 9 times or not. So you can just put a pause here. Pause means whenever your compiler will come to this line, it will pause the execution of the program until you press any button from the keyboard. Okay, so let's just write I comma j, so we can see the value of I j here. Let's just run this program. Now it is in the debugging mode, so you have to press any key. Now I is 1, j is 1, just press any key. I is 1, j is 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2 and 3 3. Okay, so the loop is running 9 times, it's okay. So let's just remove the pause from here, and I want to find out that whether this loop and whether this particular condition is working or not. So let's just put a pause here. Okay, if this condition is working, so this program will stop at least once at this place. Okay, let's just run this program. So now the x is this and this is the result, but our program is not paused anywhere. So it means this particular expression is not working. So there might be some another logical error. Okay, I'm not gonna tell you what is the error in this program, so that you have to find out on your own, because we will be using this program also for the autonomous debugging. So in this case, you can use pause anywhere, but when you are having some long programs or some complex programs, then in that program you cannot use pause everywhere, and you cannot use the variables which you want to analyze. So it will be very complex and very time consuming that you are writing each of the variable without semicolon and using pause everywhere. So it's quite not practical. Okay, so there must be some an efficient way. So yes, MATLAB provide a very efficient way for this kind of things. We are having autonomous debugger for these kinds of things. Okay, so in the autonomous debugger, you can put a breakpoint anywhere. Suppose I want to analyze my program from the 4th line. Okay, so just click here, the red button will show here, red marker will show here. Okay, and just run your program. When you will run your program, your execution will stop at 4 and it is showing that it is stopped in debugger. Okay, so now you can move this program step by step. Okay, when you will click on step in, it will move on the next line. The main advantage in this debugging mode is when you hold your cursor on any of the variable, it will show you all the regarding values present in the variable. So let's analyze the value of x here. So x, we are having this matrix. Similarly, we are having r is 3 and c is 3, and just click step in, and now I is 1, again click step in, so now it is j is 1. So in this way you can analyze how the loop is working also. So now this condition is fulfilled, so why, that's why it is in 7th row, and now the next cursor will be moved to the end, and now it will go to the inner loop again. Okay, so in this way you can analyze the complete program and you can analyze any variables value anywhere. Okay, so in this way you can just step in and just analyze the complete program line by line. Okay, and you can also put more than one breakpoints, and if you want to exit from this mode, you have to just click on quit debugging and it will exit from this mode. Okay, and you have to just remove this point by again clicking on this button. So in this way you can debug your programs, although Still I haven't tell you what is the problem in this program. So this is also a question for you. Just solve this thing, that what is the logical error in this program. So this was all about the errors, pitfalls and debugging. Thank you very much.